Okay, let's do testing for proteins. It has this wonderful statement: proteins are remarkably versatile and structural molecules found in all life forms. Okay, so proteins are composed of, here's your important stuff, amino acids, each of which has an amino group and a carboxyl group. The amino group is where the nitrogen is, and the carboxyl group is C with a double bond O and then an OH. So it says the amino group on one amino acid is linked to the carboxyl group on the adjacent amino acid by a peptide bond. Let's scroll down here for a second and look at peptide bonds. So here's your carboxyl group, here's your amino group, and what happens is they go through dehydration synthesis, so OH and H will come off and form water, and then the bond is formed between the carbon of one and the nitrogen on the other. The double bond O is still there, one hydrogen is still there. That's what your peptide bond looks like. So, the Biuret test is what we will use to test for proteins, the presence of proteins. It's a 1% carbon sulfate or copper sulfate solution. So in this test, the copper complexes with the peptide bond, producing a violet color. So violet is the positive test for the presence of protein, and it says the intensity of the color relates to the number of peptide bonds. So if you want a bright violet color, you have to have a lot of peptide bonds, which means a larger protein, many amino acids joined together. So how are you going to do the test? So you're going to get 5 test tubes, number them 1 through 5. You're going to add the materials listed in table 2, and I think that's like egg and honey, and there's a few other ones. Then you'll add 2 milliliters of 2.5% sodium hydroxide because it has to be in a base. So you have to change the pH before you get started. And then you'll add the 3 drops of Biuret reagent to each tube and mix and record the color change of the tubes. So that's proteins. Let's look at lipids. Lipids have a bunch of molecules that dissolve in solvents such as ether and acetone, but they do not dissolve in polar substances such as water. So as you know, oils and waters do not mix. So also you need to know that the primary component of fat or lipid is the fatty acid, and that is mostly carbon-hydrogen chains. 3 fatty acids are bonded to glycerol. Yeah, we don't need to do all that. When the bonds do bond to a glycerol, it will make an ester bond, and so it kind of looks like a head with a bunch of carbon-hydrogen tails hanging off of it. So we are going to look for the ability of fat to dissolve in different substances and how they absorb different pigments. So solubility of lipids in polar and nonpolar solvents. So you're going to get 2 test tubes. One of the test tubes you'll add 5 milliliters of water. To the other one you'll add that should be milliliters, not meters, of chloroform. And if we don't have chloroform, which we might not because it was an old bottle a long time ago Mr. Johnson had, we will use acetone. And then you will add a few drops of vegetable oil to each tube, mix it, and write down the results, what happens. If we have the Sudan 4, then we will do 5 test tubes, number them 1 through 5. You will add your materials listed in table 3, the same materials that I mentioned before, the egg and the honey. You will add 5 drops of water to tube 1 and 5 drops of Sudan 4 to the remaining tubes. So your water adding is your control, your negative control, and then your Sudan 4 would be what you add to see if there's a positive change, and then you record the colors of the tubes after you're done. Here's an example of the ester bond I was talking about. Here's your long chain fatty acid, just carbons and hydrogens. This is where it would make your bond. There's an OH and a hydrogen. Every time you see that, you probably get water that comes off, and then it can join. So there's actually 3 locations, 1, 2, 3, on the glycerol. So you can get a triglycerol or a triglyceride you might have heard about for a lipid. You can also do a much simpler test. So if we don't have the Sudan 4, we'll still do the vegetable oil one and then the grease spot. But what you'll do is you will take a piece of brown wrapping paper or brown paper bag. You will use an eyedropper to add a drop of salad oil near the corner of the piece of paper. Add water near the opposite corner and let them evaporate, and then look at the paper as you hold it up to the light. And then what you'll do is you'll test the other 5 solutions that I mentioned, or other solutions in that way as well. Okay, so that's how we're going to test for proteins and for lipids.